Hi, good morning. So I've been doing local first for a lot longer than local first was a thing. I hope you can all hear me. That sounds fine, good. Yep, I'm gonna talk a little bit about what I've been doing in the past couple of decades and how I achieved hero status, I guess. I'm not a hero, please. My name is Jan Lehnardt. I'm a developer and business person here from Berlin. I'm the PMC chair for Apache CouchDB and Apache PouchDB. And I've been doing computers since 1988. I've been on the web since 1998, and I've been doing computery stuff ever since. In my day job, I design, build, and maintain offline-capable systems at Neighborhoody Software with my lovely team, some of which are here. I want to start out by thanking the organizers for putting this together and for putting me on stage. It's a great honor. It means a lot to me personally to see so many people in one room that are all passionate about the same things that I'm passionate about. When we started out talking about data sync and disconnected networking in 2007, we had no community. We had no community. We didn't even have words for the things that we were talking about. It took us until 2013 to come up with a term that kind of captured our intent. I coined the term offline first. Thanks. In collaboration with my friend and coworker Alex Feierke, who went on to write the seminal article about it. And it's just so very nice to see so many folks coming together, albeit under slightly updated terminology, but I'm seeing a direct lineage between what you're all about and where we were coming from. So I'm just very happy to be here. This is super cool. I am, of course, all about CouchDB and PouchDB. I'll give you a brief historical background for where they're coming from and why they exist, by way of showing you, hopefully, that your history is a lot longer than you may be thinking, and that there's a lot of things to be proud about to be at this stage today. I briefly explain how they all work, so you get a sense of why they work the way they work, and then I go into a bunch of projects that we've done with them. So all this background is so you understand the projects a little bit better. So I've been doing CouchDB since 2007, and the one reason why CouchDB exists that it has a peer-to-peer protocol and replication engine or synchronization engine built in. That's the one thing that's cool about it. And it was pretty astonishing at the time, but it was originally modeled after Lotus nodes, which is decidedly not cool. Absolutely not cool. The original design in the late 80s or mid-80s is that you had an office with network computers where you did all your stuff, send reports back and forth and fill out forms and do all the things that you need to do to like whatever you do with your business. And some of these computers were portable, not in the way that we know today with laptops, but they could take these computers and take them over to their customers, and then at that point had a full copy of all the data that was relevant to that customer and to the rest of the business, so they could file new reports, update spreadsheets, do whatever they needed to do to make sure that work with that customer worked out, while fully disconnected from their corporate network. And then they can bring these changes back in to the corporate network, and then Lotus Notes would make sure that all the other computers would get all these changes, that reports were filed correctly, that emails were sent, and all that kind of stuff. If that use case sounds familiar, taking stuff somewhere where they're not connected to the network and then bringing it back in and then reconciling all the changes, well, you may have heard of this before. So that was the original idea here. So the inventor of CouchDB then, Damien Katz, thought that's a pretty cool idea, but it should exist as an open source database. And this is how CouchDB came to be, which is pretty nice. But at the same time, two very important papers came out. The first one is Amazon Dynamo, which is a paper that explains how to build large-scale fault-tolerant database systems. And the other one is Google MapReduce that explains how to use as many computers to do distributed computing very quickly and efficiently. And we built both of these things into CouchDB. So in addition to being good as this offline scenario, it's also very good to be a large distributed, highly available database network cloud, if you want it to be. So that's a pretty unique package there that we have in CouchDB. In 2010, PouchDB came around. It is written in JavaScript, targeting the browser and Node.js, and nowadays other JS engines, of course. Has the same API as CouchDB. and has the same data synchronization model and engine built in. And it mainly exists because I said it couldn't be done efficiently. And this is one of my most successful cases of what I call SDD, spite-driven development. The inventor of PouchDB, Michael Rogers, wanted to prove me wrong so bad he built a thing, and I'm so glad he did. Briefly to explain how it all works, Couch and Pouch have the same data model. You have databases like in other database management systems. You have multiple ones, so you can organize your data if you want. Each database has documents in them, documents where you do basic CRUD operations on them. Documents look like this. They have a primary key that's an ID. That's just a string that you can give or that CouchDB can preload for you. It has a revision, which is a content addressable hash, so we can differentiate different versions of the same document. And then the rest is just whatever data you want, just the JSON that you have in your application, in your models. You could just serialize it into there. And because we can differentiate between different revisions of a document, we can also say these two revisions are now in conflict. And specifically, we can have multiple of those. You can have 3, 4. You can have as many conflicts as there are required to represent whatever state the data was in, and then give you all the tools to resolve those conflicts yourself. There are some libraries that help you make this a little bit easier, so you don't have to worry about each case. So that will be handled for you. But for some final edge cases, when a computer can't decide anymore, you get all the tools to make sure that your users can do the right thing in the face of a data conflict situation. Some other fun stuff, you can store binary data in Couch and Pouch. That's very useful. And all the other fun stuff that databases do with secondary indexing and all the goodies are all in there as well, but they're not relevant to the local first offline first use case. I need to take a breath here. So back to the synchronization. In CouchDB, replication and synchronization is used interchangeably. We call it the replicator. It's the thing that does that at all. It's built into all of Couch and Pouch. And the replication primitive for us is replicate everything from node A to node B. So that everything that is on node A is on node B. And from there, we can build bigger replication topologies. If you need bidirectional replication or sync, you just have another replication going in the other direction. Or you can build then a one-to-N situation when you want to fan out. You can have an end-to-one situation when you collect data on mobile phones and have it all go into the cloud. Or if you just build interactive apps, they go both ways all the way with data sharing and all that kind of stuff. So that's all taken care of. You can take this pretty far, and some people have. Build a big data mesh if you want. The replication model doesn't care about how many nodes there are and how well they are connected or not. The really interesting thing is, of course, geo-distribution, where you can put CouchDB instances close to your users so they have low latency access to things, or for fault-tolerant reasons. And as I said, CouchDB does not care how far these are apart. You can spread these far, again, to get close to your users or to have redundancy. CouchDB really lets you build this. That's just all out of the box. There's nothing you have to do. This is just setting up CouchDB and pointing them at each other. So all of this is done in HTTP and JSON, all open standards. PouchDB is written in Erlang. It's good for servers and desktop computers. Again, PouchDB is in JavaScript. That is now in all the runtimes. It's helping there. And engineering is all about trade-offs. And the one trade-off that CouchDB and PouchDB always make is data safety is more important than everything else. When you give a piece of data to CouchDB, it will then make sure it won't lose it, and it will make sure you can get it back. That's one of the core tenets. If we build out new features and we can't make sure it is safe, that your data is safe in this, we'll find another way, or we not ship the feature. That's just very, very important to us. Both projects are now part of the Apache Software Foundation, which is a vendor-neutral space for open source projects, or how open source projects are managed. That means no one company owns these projects. No one company can take it away, can start charging for it, or take it into a direction that you don't like. And there's rules and guidelines for everybody to contribute as well. So you can all join and help if you want. Of course, there's commercial services available, like my company, but it's not just a single vendor situation. That's going to be important later. And then quick summary for the use cases that we have. If you need a database, use CouchDB. It's a good database. Give it a try. If you need a scalable, highly available data cloud, use CouchDB. It does that pretty well as well. Check it out. But the thing that's interesting to all of you, of course, is building offline capable systems. Just examples from like customers that we have that do these kinds of things. Offline capable points of sales terminals or mobile devices for hospitality or retail or maritime operations. If you want to build that Orca fan club, you can do this all with this. We can do in-the-field data collection for researchers or field technicians, like people come out and like fix your fridge or freezer, but in your basement they don't have an internet connection, but they need to like order a new replacement part. These kinds of systems you can build with this very easily. Also remote operations, like say archaeology or healthcare in locations that don't have a lot of infrastructure, where archaeology usually happens, or like in the jungle or in the mountains. And then thirdly, anytime you care about user experience, talking to localhost is usually the lowest latency option available to you. So that way you can build really fast user experiences. That is a nice side effect of all this that has been mentioned before yesterday as well. All right, so through our work on Couch and Pouch, my team at Neighborhoody and I got to work on a number of extraordinary projects. And for each and every one of them, I would suggest, or I would consider them a once-in-a-lifetime opportunity. But it turns out that if you prove that you're capable of like thriving in a crisis, you'll be called upon and again. I have to stop for a brief content warning. I'll be talking about human suffering, death, medical jargon. I'm not going to show any pictures, of course, but if you're like me, a little bit sensitive around this stuff, just heads up that that's coming now. So, our once-in-a-lifetime project number 1. Stemming the 2013 to 16 Ebola pandemic in West Africa. In 2013, in Guinea, Sierra Leone, and Liberia, there was a large Ebola outbreak that also, to a lesser degree, affected Mali and Nigeria, and we were called in to help. The time at which we joined, this is a number of cases per country, it wasn't clear if the epidemic would remain an epidemic or would turn into a pandemic. And I don't want to make light of this, I just want to demonstrate how high the stakes were. We're all a bit blasé about pandemics these days, because we've done one, but the mortality rate for COVID globally is about 1%, and the global average for Ebola is about 50%. And even in countries with good healthcare like Germany, it's still 25% versus 0.17% of COVID. So an Ebola pandemic would have been quite the disaster. And just to, make sure we honor everyone here, 11,323 people died in that pandemic, but that's only the confirmed cases, with the unconfirmed cases being up to 70% more. So the real numbers are really, really scary. So how do you go in and fix this? The main thing that you have to do in this situation, especially when no vaccine is available, is a non-medical intervention called contact tracing. It's very simple. Find everybody who shows symptoms of Ebola or tests positively and quarantine them, and then find all the people they were in contact with since they showed symptoms, and quarantine them and monitor them for up to 21 days to see if they start showing symptoms, and if they do, quarantine them as well. Recurse your way through the population until you're done. And that was done when we started, but it was a paper-based process. People would get like stacks of paper. Here's all the people you have to go to follow up on a piece of paper and with a checklist and everything. And then they would drive there and fill it out and come back to the central office, and then all these spreadsheets would like scanned or manually typed into spreadsheets so they can see, oh, this area had a little bit of growth of infections or so, but it was extremely tedious. So we were called in to turn this into a digital solution. So we built an offline capable mobile app with bidirectional synchronization. In the morning, you can load up all the people that you had to follow up with into your app. We had a quick search on there. You can find them real quick. We built a zero friction UI, so you can enter all the patients or the people's symptoms real quick, so it doesn't get in your way, and so you get through more people than you maybe would do if you do documentation on paper. And then when you come back in the evening, we collect all the data, synchronize it to a cloud, and build pretty dashboards so we actually can see actual heat maps overlaid on real maps to show, hey, this area has an increased raise in symptoms. Maybe we should send some more humanitarian help that way. So we built all that. Some of the challenges, on-device storage limits, even though any individual phone didn't have that many records on them, people did fun stuff with their phones. That's a nice anecdote for later in the talk. But on-device storage is, at the time, has been a very tricky thing. One of the problems is arriving at the position where we can actually get to the zero friction UI. The whole operation was so fast-paced that essentially we were doing single-day sprints. In the morning, we get requirements, then we build and ship them. Next morning, we get feedback and new requirements. And sometimes this led to, for the course of a whole week, every morning getting 180-degree opposite requirements from what we get the previous day, and then that just continue every day until we got it right. So that was, was very tricky. We all had to do this in 3 languages for 5 countries, including all the differences for requirements for documenting and healthcare standards and all of that kind of stuff, so a lot of complexity. We also built a call center. Quarantining people means they're taken away from their homes, sometimes hundreds of kilometers away from where they live, so their families need to be able to find them. We give them like a tracking code, like a booking code you get for traveling, so that their families can call the call center and find out what happened to their family member. Initially, we built this on the same technology stack because we had no time to invent anything new. So we had a bunch of laptop computers in call centers and had PouchDB in there that would then replicate the full set of call center data onto their local machine and then deal with it. But the amount of data and data churn showed that with the hard-end software available at the time, that wasn't very efficient. Loading times were slow. People were complaining this solution would get in the way of things. One thing that saved our bacon here is that PouchDB was designed for 2 different JavaScript environments, Node.js and the browser. And the data persistency in both situations are different. So we have an abstraction layer in the middle, so you can pick how to actually store data. And one of those is an HTTP layer, which means it turns PouchDB into a CouchDB front-end client, basically. So we just took PouchDB out, the storage part of PouchDB out, and had it talk to the cloud directly. That saved the day. It's a 1-line change in the application to just change the storage adapter. That's very nice. And then the next day we found out not all call centers have reliable internet connections. Yep, back and forth all the time. So we put an in those data centers, as call centers, we put in a CouchDB on one of the laptops that acted as the local server that was always available, had low latency access, and that would then make the people using the app interactively happy, and then over the somewhat degraded line would asynchronously up and download everything from and to the cloud, and everybody was happy that way. The number of code changes we had to make for that is 0, because that's just how CouchDB works. You just plug in another thing, you set up replications, and you're done. So CouchDB eats these problems for breakfast, which is very nice. Third thing we did is a vaccination trial software. So I think we're all familiar with how vaccination trials works these days, but you have a group of people, split them in half, 1 get a vaccine, 1 get a placebo, and then you monitor progress of both groups and then compare infection rates and infection severity. The problem, so fundamentally we took the same app setup again, built an offline capable app, so we could follow up with people, very similar to contact tracing. But people get paid to be part of clinical studies, so naturally they try to game the study to make sure they get more money, which is bad because that invalidates the study. So we had to figure out a way to uniquely identify people so they can't trick us. So we hacked up a fingerprint scanner to an Android tablet that would then connect to our software stack, which, getting to this, for this we built on desktop computers, we just used a browser. On mobile devices, we used Cordova PhoneGap, to wrap up a web application to make it available on native. The app development was done in Angular and PouchDB, and then the backend is in CouchDB and Node.js, like a very lean stack here. Things that we accomplished. No pandemic, you would have heard, trust me. So shortly after we started, the numbers were, like the growth slowed down. The number of cases, if you're in the field, even until the end of 2016, were very scary, and the potential of them going up was always in the cards. But yeah, we made a significant dent over here. Thank you. we did real impact. We helped first responders and other personnel to help humans in need, and the gratitude we got back from the field was just amazing. People loved what we were doing, and we loved doing the things. The call center software helped reunite families, and in the sad case, helped provide some closure, which is, given the circumstances, also very important. So it's just a very human need that we helped fulfill there. And then finally, out of the vaccination trial, the first ever Ebola vaccine was actually approved. So that's pretty cool. Thank you. So the once-in-a-lifetime project number 2 over here is COVID vaccination logistics for Bavaria. Bavaria is Germany's biggest state by area and second biggest by population. It's about 13 million people. And our scope was from BioNTech Pfizer giving us the vaccine, cooling pipeline and everything, all the way to people get a jab in the arm. That's our scope. And we had 3.5 weeks to do it. So what we did here, this was part of a bigger team, and our specific team was working on the jab documentation, which is where we record who got vaccinated, by which doctor, with which charge of the vaccine. So if something's wrong with the charge, we can find all the people who were vaccinated with it to give them the help they need, and so on. We had to aggregate all that data that we got in by various cohorts, age, gender, region, and so on. We had to manage patient records, of course, which is always scary, and because we weren't actually allowed to see any of the personal, the medical data, and even some of the aggregated statistics we weren't allowed to see. All of this was encrypted on device with public key encryption, to which we didn't have the private key. So that's fun to test, believe me. And then our system worked so well, and we found a lot of problems in adjacent systems that we had to build a telemetry system that proved that our stuff was never at fault. Challenges that we have here. This was initially designed for mobile vaccination teams because the initial cohort for receiving vaccinations was the 80+ cohort here in Germany, at least. I think we did this everywhere. And old folks home traditionally don't have very good internet. I hope that changes when it's my time, but at the time, we really had to make sure that doctors could go in, vaccinate as many people as possible, record all of the data on device, and then when they got back into a situation where they could synchronize the data back, that was possible. So we built, again, seamless offline application again with data capture and sync, very similar to the other stuff. For the user interface, it had to be fast, correct, cheap, and accessible, and we had to pick all 4. There were no shortcuts. It has to be fast. The more people doctors can vaccinate, the better. The faster they can do it, the better. But they had to do it absolutely correctly, because in this situation, it's very important that a doctor has all the information they need to do the vaccination correctly, or refuse the vaccination if there are any contraindications like allergies or something like that. So it's literally a life and death situation. If you have a little bit of a record missing, that's not an option here. It's a public service, has to be accessible, all of these things. And they're cheap in terms of we had to build this quickly. Right. I already hinted at the data compartmentalization. So the Bavarian state needed all the aggregation numbers. The health ministry needed all the medical records and documentation that we did for legal reasons. But they weren't allowed to see each other's data, so they had different private keys for all the public keys for their data. And then media got data updates. The doctors needed to be sure they have all the right info. And at some point, and we had to make sure, because in a crisis, you could imagine all data privacy laws, we pause them so we get through this really quick. Not in Germany, of course. So in the vaccination centers at some point, we had non-medical staff collect medical information into a website just on the client, and then print a QR code that had the medical data encoded in it, and then flushed from memory. So the non-medical staff actually didn't have access to go back to that information. And then the people who were vaccinated would take a piece of paper with the QR code to the doctor, who scanned it then and then had a full patient record there. So they can, we made this asynchronously, so the doctors could just vaccinate. If you went to the vaccination center, it went pretty quickly, right? Go. So sometimes SneakerNet is the answer. That was pretty neat that we did that. Technology stack here, desktops, all the browsers, on mobile, Cordova on Android and iOS, app development in React and PouchDB, and backend again, Couch and Node, and the other teams use Java and MS SQL because that's where they were fastest with. Accomplishments. We started in early December of whatever year that was. Who can remember? And on December 26th, of course, we had canceled Christmas for this. On December 26th, I was logged into the server with a terminal and could see, hey, first records that I couldn't see what was in there, but I knew this now represented someone from the 80-plus cohort getting the very first COVID vaccination in Bavaria. I will never forget this. It's very, very cool. We didn't lose a single piece of data, and we didn't leak any patient records, as far as I know. And we got vaccinations to millions of people, so that was quite satisfying in terms of building an offline capable project. Thank you. All right, once in a lifetime project number 3. It's route planning for humanitarian relief convoys in a war zone. It's a thing I have to be a little bit vague about, so don't ask me about specifics because it's an ongoing situation. And we had 3 weeks. This time we could cheat a little bit because there was some existing software that we could help adapt, move forward, so that we had a little bit of a head start, but we were still very busy in those times. The main problem to be solved here is that if you plan a relief effort or a convoy to go through a certain area, and then you go on the convoy, you might find yourself that certain obstacles, roads and bridges that no longer exist, and you have to deal with routing around it. So our task at this point was building an app that you could paste in a GeoJSON route that would come from like QGIS or Esri or even Gmaps, where somebody did route planning. And then we had access to high-resolution satellite imagery that was very, very recent, like the really good stuff, if you've ever seen it. And then the app would individually, automatically from the phone, download all these high-resolution tiles at different scaling, like zoom levels, just around the convoy route, with a little bit of gap left and right. Figure all that out. And then in the situation where there was an obstacle in the route while on convoy, went absolutely definitely offline, they could look at the surrounding satellite imagery to see if there's to find a safer path going, where they could go with this. Challenges again had to work fully offline. In the synchronization sense, it was relatively easy because it was only unidirectional from server to the mobile device, but the storage on the mobile device had to be was large amounts of data, and it had to be absolutely reliable, not only from a technical perspective, but also from a user interface perspective. So you can't leave a convoy stranded if you lose a map tile. That's very bad. And we didn't have a lot of UI space to tell people when they do the planning, they can trust that all these tiles were there. So we did a little trick where the tiles that were actually safely downloaded had a slightly different tint to them than the rest of the map, which was like loaded dynamically while they were still at headquarters. So they could rely on, okay, this data actually will be available when in the field. It had to work. Oh wait, I said all these things already. Sorry about that. The tech stack here. Well, you see I skipped the accomplishments. Again, I can't talk about this. The tech stack here, again, was mobile app using Capacitor for iOS. Capacitor is a newer version of Cordova PhoneGap, and then app development was in React and PouchDB again. Backend, Pouch and Couch, the usual suspects. All right, running a little long, but I'm getting to the good bits now. The lessons learned. Number one, if you're open about your values and your capabilities, the projects that suit you will find you. Like, just talk to people about what you do, what you're interested in, blog about it, attend events like this, and just like chew everybody's ear off about what you're passionate about, and the project that you are passionate about will find you. Lesson number 2, you need a software stack that you can trust. It's one that doesn't get in your way when you have very rapid development cycles, when you have to rewrite your UI every day for a week. And that you can trust and that you can also make others trust. And specifically, in Couch and Pouch's way, situation, it is a very simple programming API. It's basically a CRUD API, and then the thing happens magically. If you attended Alex's workshop on Monday, we'll put up a recording of this later as well. You see, there's not a lot to actually building useful things on top of Couch and Pouch. You need to have reliable storage. That's why I harped on it earlier. That's the number one thing that these systems do. The data is safely and reliably stored. And you need predictable operational behavior, which PouchDB written in Erlang gives you. It's very sweet on servers and all that. It really helps if your software is open source. It really helps if you build on open standards. And it really helps if your projects are open governance projects, where if you tell, it's like if you go to the Red Cross or the United Nations and say, hey, we want to build this thing for you that you really need, but you have to talk to the sales department first, there's no way you get anything done in 3 weeks. Lesson number 3, people lie. The folks who did the contact tracing had a very grueling job. They sometimes had to travel hundreds of kilometers to go to the places where they did their thing. Of course, they used the phones we gave them to make their days a little bit lighter and easier and more fun. So they downloaded all sorts of apps onto those phones, which ate into our storage budget. So we had to come up with very creative solutions to work around that, and to make sure that we can reliably capture and sync all the data that we were capturing. The other lie is the people who run vaccination centers have varying degrees of understanding of what it means to have reliable internet connectivity. Some of them just don't know. Like, we have dial-up, it's worked for ages, right? Or, like, yeah, we have this one Fritzbox here, it's fine. And then hundreds of PCs trying to get in on that Wi-Fi. It's really bad. So we had to build a whole, like I said, the telemetry system, so we could go in, hey, vaccination center, computer number 14, could you move that like a meter closer to the Wi-Fi router, and then you'll get all the data that you're missing. And they were always telling us our software was wrong, and we told them their network is wrong, and we were always right, and we could prove it. So people lie, you have to work, don't let that stop you, just work around them and move on. I've harped on this as well, lesson number 4, user experience and data reliability. If you get in the way of people using your if your software gets in the way of people getting their job done, they will route around it, they will go back to the old system, they will not get any of the benefits of your solution here. So user experience is really the key here. And part of that is data reliability. If they put in data and that somehow they can't find it later, they don't trust your solution as well. You need stable synchronization for this. You can't do any nonsense like last write wins, which just means randomly throwing data away, which we just couldn't do in these situations. And again, build the telemetry to prove that it all works, because people won't believe you. But if you do this correctly, user experience and data reliability build the trust in the solutions that you build. Lesson number 5, we couldn't have done this without the web. The work that goes into web standards, building browsers, the libraries on top of that, and then the frameworks that allow us to do rapid development. Like, there's no other platform like it. It's absolutely fantastic. Yes, we had some native bits in there, but if it wasn't for the web, we couldn't have done any of this. So thanks everybody who works on web technology. Thank you. 2 more. Documentation is a superpower in the Ebola project. We had to onboard and integrate into this, hire and onboard into the team the equivalent of a senior developer, designer, product manager every week for the span of 3 months. And at the speed that we were going, we couldn't say, okay, now you sit down with the team and learn everything. We had to write everything down as we were writing it, so these people could catch up on their own and then join the team. Without documentation, we couldn't have done any of this, so get good at that. It's a really magic multiplier for your time. Same is true for the Ebola, for the COVID project. We had to document everything, also because eventually everything was fast-tracked, of course, but eventually we would get legal, security, all sorts of reviews to make sure these systems actually work correctly. And if we hadn't documented them in time, we wouldn't have got those certifications done. So document, if there's any 10x multiplier to your development speed, it is documentation. It's the only thing that gets you there. And then number 7, it turns out you can get a lot done in 3 weeks. A mission can galvanize a team like nothing else. For me, helping other humans is the ultimate calling, and it's ultimately so much more rewarding than chasing a startup exit or market share or whatever else you might be doing. So for me personally, These projects are what get me up in the morning. It's not the high availability work, which we also do, and not the geoscale work, which we also do, and the big data work, which we also do. But these projects validate all the time and sweat we put into CouchDB and PouchDB themselves, and to our work helping others getting started with it. In 2116, when we're going to write the list of human achievements of the past 100 years, first ever Ebola vaccine is going to be on that list, and my team and I have worked on that, and that just makes me immensely proud. It is always worth remembering that the positive impact that your technology has is as important, or sometimes even more important, than all the other factors. I hope you enjoyed this bit of historical context and real-life anecdotes, and I hope this inspires you to do meaningful things with all the cool technology that you are building. Thank you.